This lecture I am delivering because of some student. They requested me to give this lecture. So this topic is a comparison of EMF using potentiometer. So comparison means to find the unknown EMF, right? So this here E1 and E2 are my EMF. Okay, so E1 I have considered this as unknown and E2 is of course my known. So using this potentiometer we can also find the EMF of unknown cell. So what is EMF? Please do not confuse. The full form of EMF is electromotive force, but this is not a force. This is a potential difference between the two terminals of the cell when there is no current. Okay. So using this potentiometer, we can find the EMF of unknown cell, okay, with the help of the another cell whose EMF is known. Okay, so this is the diagram how it look like, but please remember this diagram may differ from book to book. Different author will give the different diagram, so you can follow anyone. So for me, I found this is the best way, so that is why I am drawing this one. So it is unlike meter bridge. Okay, there are so many wires. Okay, there are so many wires. You must have seen how a potentiometer look like. Okay, so this is my source or a driving battery which give constant current in this circuit. Please remember, this source or driving battery gives constant current to flow in this circuit in the wire of all this potentiometer. Now, so whenever I connect this K1 in the circuit, what will happen? The constant current will start flowing in all this wire, right? Now see, what we know is from the circuit equation, we know that EMF is equal to V plus IR. Okay, V plus IR. What is R? This R is the resistance of internal resistance of EMF, and I is the current flowing in this through the shell, and V is the potential difference. Now, okay, so we have selected this circuit. We select in such a way that what we do is, first of all, we'll connect. Okay, please remember I have connected K1 giving the constant current. Now let me connect K2 with 1. Okay, whenever I connect K2 with 1, okay, connect K2 with 1. So what happened is the unknown EMF E1 will come in the circuit, right? So what happens is, then from this equation, okay, from this equation what we know is, we know this E is equal to V plus of IR. Very simple. Okay, this is I'm going into the depth of this theory. Okay, so none of the book have written this kind of thing. So what happens is, now what I do is, you have studied the meter bridge also, in which I move the jockey. So similarly here I will move the jockey connected with the galvanometer, and I will find the point in which the current is 0. Okay, in which the current is 0, that is called the null point. So whenever I say current is 0, which current I am referring here? The current which is flowing through this EMF. Please remember, the current which is flowing in this all the wire is constant due to this one and with this rheostat. Okay, so by changing this we make it constant. But whenever I connect this K2 with 1, this EMF E1 is included in the circuit, and moving the jockey, sliding the jockey over the wire, I find this I in this cell is 0. So this is what? This is my, so this is R internal, and this is E1, I in E1, right? So how much is the current I whenever I found this L1? Okay, so where L1 is null point position, in which let's remember current is 0 in epsilon 1, that is E1, that is EMF. So I have connected, finding this balance point, null point. I found that there is no deflection in the current. I mean, no, the deflection in the galvanometer is showing at 0. It means that there is no current. No current means where there is no current. No current in the E1. Okay. So what I can write is E is equals to V plus 0, because this is become 0. Now what is V? Please remember what is V. So V is the potential difference between this point and this point, because in this wire the current is always flowing, right? In this wire the current is flowing because of driving cell. So here V is potential difference between A and L1. Please remember, V is potential difference between A and L1, and this is how much is this? Okay, so this one will be my E1. So E1 is equal to V is equal to IR. Okay, IR, and this I is constant current flowing in the wire due to source, and we know that how much is R. We know this is equals to I into rho L by A. Okay, because R is directly proportional to length, inversely proportional to area. If I remove this, this will become equal rho. Okay, this is how it look like. Now what is the length from this? 100, then 150, 200, and so this is my L1. So L1 is equals to I into rho L1 by A. So this is equation number 1, right? So it is very simple. It is very simple. Now let me pop this out. So what I got is, I got this one. E1 is equal to I rho L1 divided by A. Okay, this is from now what I do is connect K2 with 2. Now second step, connect K2 with 2. Okay, what happens is then this known EMF will come here. Known EMF will come in the circuit like this. It will be looking like this. Okay, now let the balance point has been found here, L2, when it is connected with E2. So what happens is, again, whenever I connect it with E2, at L2 I find no current in E2. So similar to the first one, I can write E2 is also equal to V, right? V is what? Potential difference, and V is equals to IR. Please remember, this current is constant. Whether you take E1, whether you take E2, because of this driving cell, current in this wire is always constant. So what I can write is I, R is rho, L by A again, and L2. Now why I am not changing rho and A? Rho is resistivity. All the wire is made of the same material. For first E1 also the wire was same. For E2 also wire was same, and therefore the area of cross section A is also same, right? So A will remain A, rho will remain rho, but the change there is change in the null point for E2. So for E2 null point is L2. So this is E2, so equation number 2. Okay, this is equation number 1. So which is unknown? E1 is unknown. So I want to find E1. So what I do is I will just divide equation 1 by 2. I will get E1 by E2 is equal to whole divided. What is there? I rho. Okay, so let me write rho properly. Rho L1 by A. Again I rho L2 by A. Okay, so I cancels, rho cancels, A all cancels, then I will get what? I will get E1 by E2 is equal to L1 by L2. Very simple. Now L1 we can measure it here, okay, because it is given in meter scale. L1 we can calculate, L2 we can calculate. If E1 is unknown, you can get E1 equals to L1 by L2 into E2. If E2 is unknown, then you will get E2 equals to L2 by L1 into E1. It is very, very simple. Now in some book, what they do is they will directly write E is equal to phi L1. It is absolutely correct. But what is phi? Phi is some constant which is called potential gradient. Potential gradient, which I will not discuss what it is in fact. So this is, if you find E1 is equals to like this, it is okay. If you find E2 is equal to phi L2, it is also okay, no problem. But this is quite, I am doing it in depth form. So again, if I divide this by this, what do I get? I will get E1 by E2 equal to phi L1 by phi L2. Again, same thing. This is quite short. If you want to do like this, you can always do like this. If you want to do like this, you can always do like this. Both are same. Now, sometimes question is asked in the board examination, what could be the possible reason for one-sided deflection in galvanometer? So what do we mean by one-sided deflection? It is because you have a galvanometer, okay, you have a galvanometer, this is 0, 5, say 10, 5, say 10, and it is always here. This will deflect at always this point. Whether you place this jockey here, whether you place this jockey here, it will always show at one side, this one, or either it will show this side or that side. Whenever you slide the jockey over the wire, it will not change its position. Why? It is because that the EMF of this cell is larger than the EMF of driving cell. Now, one possible reason is this one. If the EMF of driving cell is less than this EMF, then of course it will not perform any experiment. It will not give any experiment. It is very, very important question. One-sided deflection, this EMF is greater than the source. The source is less than this EMF. The next possible answer could be wrong connection. Okay, of course it is an experiment, so it is a wrong connection. It is always correct. If you write wrong connection, it is always correct, because wrong connection may give the one-sided deflection. Okay, so this is all about your comparison of EMF using potentiometer. Comparison means to find the unknown. Okay, so if you want to learn with this, you can always do. If you want to do like this, you can always do. Okay, if you have any question, any problem, you can always ask me and comment and so. Okay, so this is all about this potentiometer. Thank you.